Hello everyone, welcome back to Lulumath. This video is going to go through how to solve the system of equation using all three methods for solving systems of equations. So we're going to solve it using substitution, we're going to solve it using elimination, and we're also going to solve it using graphing, okay? So let's go ahead and solve this question using substitution to begin with. So if you look right here, our first equation that we have here is 2x minus y equals 7, and our second equation is 4x plus 3y equals 9. So what I want to do is decide on which equation I'm going to isolate a variable in. And it seems to me that isolating a variable in this first equation will be the easiest thing because this minus y is minus 1y. So that's going to make my life a lot easier. So let's go ahead and label here that we're using substitution for this method, okay? So I'm going to go ahead and rewrite the original purple equation. So 2x minus y equals 7. So I'm going to add y to both sides right here. So I end up getting 2x equals 7 plus y. Now, by adding y, I didn't get the y alone, but I am getting myself to a point where the y is positive, which makes my life a lot easier. So then I'm going to subtract the 7 to get the y alone. So I get 2x minus 7 equals y. Again, it's totally okay if the y is on the right side instead of on the left side, or the variable that's isolated is on the right side instead of on the left side. Okay, now remember what we're going to do next is we're going to take our blue equation, which is 4x plus 3y equals 9, okay? And every time I see a y, I'm going to replace it with this 2x minus 7. So I will copy down 4x plus 3, and then I'm going to replace this here with 2x minus 7, and then I'll copy the rest of the equation down equals 9, okay? Now that I've done that, I've gone from having two variables in my equation to having just one, which makes things a lot easier for me. So right here, I'm going to just copy down this 4x, okay, plus, then I'll distribute the 3 through. So 3 times 2x is 6x, and 3 times negative 7 is negative 21. So I'm going to write down minus 21. Collect your like terms. 4x plus 6x is 10x, minus 21 equals 9. I will add the 21 to both sides, and I will end up getting 10x equals 30. Just divide both sides by 10, and I end up getting x equals 3. Well, now that I know what x is, I can take any equation I'd like and replace this 3 in for the x. So I will take my purple equation that we started off with here, this 2x minus y equals 7, and I'm going to replace the x right here with this 3, okay? So this is going to say 2 times 3 minus 7, or minus y, excuse me, equals 7. So now I can go ahead and just solve. 2 times 3 is 6. 6 minus y equals 7. I'm going to subtract this 6. Remember, we're going to subtract it and not add it because this minus sign that we see right here is for the y and not for the 6. Okay, so we're going to subtract the 6 from both sides, and I end up getting negative y equals 1. Divide both sides by negative 1 right here because this has an invisible coefficient of negative 1, which gives me y equals negative 1. So now we can say that our solution here is going to be 3, negative 1. So that's how you solve this problem using substitution. All right, now that we've solved this problem using substitution, we can go ahead and use elimination to solve this problem, okay? So I'm going to rewrite my two equations on top of each other. So the purple one is 2x minus y equals 7, okay? But I'm going to just move this over a little bit over here. And then my second equation is 4x plus 3y equals 9. And since this is a minus 1y right here, and this is 3y, I can just simply multiply my top equation by 3 because the least common multiple of -1 and 3 is just 3. And by doing that, I also will have a positive 3y and a negative 3y. So that makes my life so much easier when I'm trying to solve this problem. So 3 times 2x is 6x, okay? 3 times -1 is -3y. And then 3 times 7 is equal to 21. And then I'm going to copy down the bottom equation. So 4x plus 3y equals 9 right here. Then I'll add them together. And when I add them together right here, 4x plus 6x plus 4x is 10x. Negative 3y plus 3y is 0, so they cancel each other out. And 21 plus 9 is 30. Divide both sides by 10, and you end up getting x equals 3. Well, now that I know what x is, the next part of my process is exactly the same as what we did right here, okay? So I'm going to do the exact same thing as I did before. I'll copy down this 2x minus y equals 7, and then I will fill in this 3 right here for x. Okay, so I get 2 times 3 minus y equals 7. Again, we know that 2 times 3 is 6, minus y equals 7. Subtract the 6 from both sides. You get negative y equals 1. Divide both sides by -1, and we end up getting y equals -1. So we get the exact same solution that we got when we solved using substitution, which that should be expected that we would end up getting the exact same solution. Okay. Now, something I just want to kind of point out that's pretty cool when we did this all right here is that when we got to this point right here, where we ended up adding the 6x right here, where we ended up adding the 6x right here, where we ended up adding the 6x right here and this 4x together right here to get this 10x, we actually did the exact same thing here. The 4x plus the 6x gave us this 10x right here. Well, where did this 6x come from to begin with? It came from distributing this 3 to this 2x right here when we did when we tried to get the variables to match up or line up. And that's exactly what ended up happening when we did our substitution, except we did it at later on. We multiplied this 3 through to that to what is equivalent to y in this purple equation up here. So a lot of people will ask, well, what's better? Should I do substitution or should I do elimination if you're given a choice? And I would say do what you feel most comfortable with. There's advantages to both methods. Sometimes in a problem that's presented to you, substitution might be the easier option or the more practical option, and sometimes elimination will be the more practical option. But again, it's just pretty much what you feel most comfortable with. Okay, our last method that we're going to use to solve this problem is graphing, okay? And I just want to remind you that even though with substitution we can isolate any variable we want, with graphing we want to get it in y equals mx plus b format. There are other ways to graph as well, but this is generally the easiest way to do it. So we're going to isolate or get the y by itself in both equations. Well, for this 2x minus y equals 7 right here, we already isolated the y up here. So we already did all the work where we isolated y to begin with here. So we know that y is equal to 2x minus 7. So I'm not going to spend the time doing that again. So we know that one of the equations that we're going to graph out is y equals 2x minus 7. So that's what this turned into when we isolated y. Okay, now let's go ahead and isolate the y in our blue equation. So 4x plus 3y equals 9. This time, because the 3y is positive, I'm going to keep it on the left side. So I'm going to subtract this 4x from both sides. Okay, so I end up getting 3y equals 9 minus 4x. I'm going to divide everything through by 3. And I end up getting 9 divided by 3 is 3. Negative 4 over 3 doesn't divide out evenly, so I'm going to leave it as negative 4/3 x. Now, in order to graph this out, we have to identify what our slope is and what our y-intercept is. So here, our slope is 2 over 1. Remember, we always want our slope to be a fraction because we need to know the rise over the run, okay? And then here, this -7 right here is our b, or our y-intercept. So just a reminder, what this means is you start at -7 on the y-axis, okay? And this slope is the rise over the run. Rise means it goes up by 2. Run means it goes over by 1. So I'm going to go up by 2 and over by 1. Up by 2 and over by 1. And I'm just going to keep going until up 2 over 1. I run out of room. As long as you have enough points in order to connect the dots and not have to worry about your line being slightly inaccurate, because it's really important that it's accurate when we are solving systems by graphing, then you should be good to go. So let's go ahead and draw our line in right here. And we are going to write the equation on our line. So we're going to say y equals 2x minus 7, or you can write the original equation. It's up to you. Now, for the second equation that we have here, this 3 is going to be our y-intercept because this is our constant, and this -4/3 is our m. Now be really careful about how you look at this right here. We can either say it's -4 over +3, or we could say it's +4 over -3. What we cannot do is say it's -4 over -3, because these two together will cancel each other out to become a positive, which is not what we want. We want a negative slope. Okay, so I'm going to go ahead and start graphing out my line. So it starts at 3, and then I'm going to look at -4 over +3. So that means I'm going to go down 4, 1, 2, 3, 4, and to the right 3, 1, 2, 3. Okay, and then I'll go down 4, 1, 2, 3, 4, and to the right 3, 1, 2, 3. Or I could have gone up 4 because this is a +4, and to the left 3 because that's a -3. So right here, I could go up 4 from here, 1, 2, 3, 4, and to the left 3, 1, 2, 3. And that is what my line will look like. So we will connect our points, and this right here is the line y equals 3 minus 4/3 x. Okay, and remember there are infinite points on each line, but the one point that satisfies both lines is this one right here. This is our solution, which means that our solution, again, just like we got before, is going to be 3, -1. Okay. If you have any questions at all, please let me know in the comments below or at lulumath.com. You can find these notes filled in or blank at my website as well, lulumath.com. Please subscribe to this channel and share with anybody you think might find this information useful. Thank you very much. Have a great day. See you next time.